My name is Varul Dutt, and I'll be telling you about the next lecture in Git in the course Large Applications Practicum. So let's get started. So in the previous lectures, we had looked at how we can use Git for version control, keeping the files up to date and be able to go back to the previous versions of a document. Also, we can collaboratively collaborate on projects which are large in size with team members who may not be located in the same location and may be developing code on their machines but connected via GitHub and such kind of remote repositories. So there are a few more things in Git which we need to learn, and one is the aliases. So aliases are basically small short forms which we can create for different commands in Git. So for example, if we write git config global alias.co checkout, so now we can use co for checkout. We don't need to write the full form. Similarly, we can create aliases for branch as br, alias for commit as ci, and alias for status as st. And this can also be useful for creating aliases for bigger commands like reset head, where if we can create an unstage alias, then we can write git unstage file a rather than git reset head -- file a. This is a command which is used for unstaging a staged file. So this way you can also see the last commit. If you just say git last, it will show you the last commit which has happened in the Git repository where you are working. Now the important concept is of Git branching and how we can use Git, which is a very powerful feature for branching from one part of the development to another branch in the development. So idea is that when you create a commit by writing git commit, Git checksums each subdirectory, in this case just the root project directory, and stores these tree objects in the Git repository. Git then creates a commit object that has the metadata and a pointer to the root of project tree, so it can recreate that snapshot when needed. So typically when we make a commit looks like this, where you have actually the hash, the hex, and also the commit and its author and others. But within the commit, there is actually a tree which includes these small blobs which are referred to by different files, and within each blob refers to each file. You can also see further the information in that particular file. So for example, license file may contain the MIT license and other details, and similarly we may have other types of files. So the idea is that every commit leads to a tree-like structure like this, which can then be utilized by the Git to recreate the code which exists, or the state of the code which exists at the point of the commit. So generally when you make some changes and commit again on Git, you basically create another tree-like structure where the snapshot is referring to the tree-like structure which I showed you. The blue box and the yellow box is represented by the small box as snapshot A, and then you can actually see that every time you're making commit, you are creating those tree-like structures where there's a pointer from that commit to the last commit. And this is how Git stores information. So what is a Git branch? A branch in Git is simply a lightweight movable pointer to one of these commits. The default branch name in Git is called master. So we have seen in the prior slides that we had different commits, and these different commits oftentimes when we were making was referring to something called the master, and master is referring to the main branch. And as you start making commits, you are given a master branch that points to the last commit you made. Like for example, this is the last commit, so the master is pointing, and there is a head pointer which is pointing to the master. Every time you commit, it moves forward, and this is, for example, the master with the head on it, and this is also one probably tag or branch which has been created, which we will expand on after a few slides. So when we have to create a branch in Git, all we do is we write git branch testing or the name of the branch. And as you can see, now we are here in this commit. Master is already pointing to this commit. And now what happens, testing also starts pointing to that particular commit. And this is what happens when we do the branch statement. Now suppose we have to switch from one branch, which is the master, to the branch which is testing. So you need to only check out that particular branch. So you can write git checkout testing, and what will happen, the head pointer which was pointing to the master now starts pointing to the testing branch. So now if we make commits, it will move the commits on the testing branch. So for example, now why do we need to do branching? So idea is that you do branching. One reason you do branching is for doing some hot fixes or bug fixes to an existing code, which once fixed can be brought back to the master branch. So if we work on a website, we can create a branch for a new story you're working on and some work in that particular branch and then merge. Also, suppose you get a call from a user stating some issue which is critical. So you can actually switch to your production branch, create a branch to add a hotfix branch, and then you can bug fix in that branch. And then once it is tested, merge the hotfix and push to production. Switch back to the original story and continue working. So this is typically what happens, that you have the master branch, and when you get a call, you have a bug, you will branch out at an appropriate time, and then you will bring that code back into and merge it with the main branch. So how do we do that? So basically, if we have to create a branch and switch to it at the same time, we can actually combine multiple commands, and the command to do it is git checkout -b, the name of the branch. So here basically -b is creating the branch and then moving the head pointer to that particular branch. ISS53 is the name of the branch. So if we run this way, you already have a master and you will now have an ISS53 pointing to C2, which is the case here. And we have also switched to ISS53, so the head pointer is now pointing to ISS50. And now suppose we create a index.html file in an editor like VIM, and then we save it, and then we come here, and suppose we want to commit it on we have bug fixed index.html or make some modification, and now we want to commit it on the branch. So we have to add it to the stage and commit. So we can write git commit -a, adding to the stage -m, added a new footer, issue 53, and then we can commit it. So what will happen? The pointer will move on that particular branch ISS53, and it will continue to point to C3, whereas the master pointer points to the branch C2. So in this case, we have learned about branching, and we have learned how to branch from a master branch. In the next lecture, I'll be teaching you how to do merging. I like to acknowledge my peers who helped make the slides. So the activity right now in this particular lecture is to use some of these concepts and try them out, like aliasing, branching, and merging. So we already have the repository which I introduced you in the last few lectures, which is available on GitHub page for your particular group or some repository you can create, where N stands for the group number. So for example, for the first group, it will be group_1. And the repository password and username is also given to you. So what we need to do, we first can create aliases for the new command like commit and checkout. And then we can create a local name, activity3 and cd into it. And then we can actually say that clone your repository from the server. So you can actually clone a repository from the GitHub server, and then you can check out, and you can start changing the cout statements with the equivalent printf statements in the code. And now you can commit your changes to the master branch. Currently the function will give you a wrong answer for negative integer, so there is a bug. So you need to bug fix. So you can create a different branch like hotfix or something to fix that bug, and then following changes to the branch, add a check for negative numbers. So you can change the for and then check and then commit on that particular branch, and this will allow you to fix the bug. In the next lecture, we will see how to bring the changes back into the master branch so that you can merge the two branches together. So please try out all these things at your own pace, which I have taught you, and we will meet in the next lecture.